So it's really exciting to see the different applications for FDO just across a variety of different verticals. So next we're going to be talking about agricultural automation. Say that 5 times fast, by the way. And what IBM is doing in this space. So we have Joe Pearson and Daniel Eberz-Eder from the state of Rhineland-Palatinate. Oh, I didn't realize that. Thank you. From the state of Rhineland-Palatinate and Joe from IBM here to talk about this project. Did I say that right, by the way? Daniel, where you're from?
Yeah, from Rhineland-Palatinate in Germany.
There
Yeah.
you go. Got it. Okay. Just wanted to make sure I had it right. Go ahead. Take it away.
I guess I'll go ahead and introduce myself first, and then Dr. Daniel will go ahead and begin the presentation. So I'm Joe Pearson with IBM. I'm inside IBM Software's networking and edge computing business unit. And one of the things we work on is open source software. And within our open source, we work very closely with the FDO project within LF Edge. And what they've provided us with, giving us the SDK that implements the FIDO or FDO 1.1 specification for device onboarding, has been very helpful. And we've worked very closely with Dr. Daniel in Germany on agriculture use cases. And that's what he'll be going over today.
Okay, thank you. Thank you, Joe. And I will turn over to my presentation today. Hello, everyone. Today, I'm pleased to present an important topic for the future. It's a topic of resilient smart farming, enabled by FDO and Open Horizon, together with my cooperation partner, Joe Pearson from IBM and the LF Edge team. You introduced me. My name is Daniel Eberz-Eder. I'm the head of innovation and smart agriculture at the Agricultural Public Service Center in Rhineland-Palatinate in Germany. I like it very much to present it today live in different time zones. I like that very much. It is an honor for me, and I'm happy to give you insights into our project on resilient smart farming and the role of FDO plays within Open Horizon. Let's get started. And we will go to the next slide. So what does resilient smart farming mean? On the right side of my slide, you see our projects where we are working currently on resilient smart farming. And you see resilience in the event of a crisis. That's the most important part in our focus, because agriculture is one of the most important sectors in our economy, and it's a critical infrastructure, of course, and we have to take into account this part of the critical infrastructure agriculture. The first step is to increase the resilience of critical infrastructure agriculture, the digital infrastructure in smart farming. We have to consider that the vulnerability paradox we are knowing very well in IT systems, and that is the reason why we have to think about the importance of resilience in digital agriculture. And what we are doing now is to have a more holistic approach to resilience in agriculture. It's not only the digital one of IT systems. It is the part where we are looking close on it, the resilience of digital infrastructure like the cybersecurity and emergency communications with our infrastructure and our Open Horizon framework. It is for agriculture, it is also from an economic point of view, resilience meaning also we have to take into account climate change, environmental problems, and also structural change in agriculture and rural areas are very important for the whole sector and for the resilience of the sector. But we are knowing very well that digital applications and infrastructures can make a valuable contribution to solving these challenges. And that is why we are working in these projects together to solving these challenges. Yeah, in this slide, I will show you the definition of resilient smart farming. What is resilient smart farming? 3 capacities of resilience in technical systems. The first is offline first. It is essential services without an active internet connection, with the functional overall system even function without internet. That's very important in the part of a critical infrastructure. And it is a software-hardware combination. We'll show it later on. And that cloud applications with caching and synchronization mechanisms are established and implemented in these IT architecture. And the second part is data security. What that means in part of agriculture, that we have no data loss, and we have a data redundancy, a backup system like this. And what we promote a little bit more is a more decentralized distribution of data. And the third part is the integration and compatibility with open data standards. It's a challenge to do this with open data standards, but we are working on it. That we have more flexibility for larger software ecosystems and a better system customization possibility in our resilient smart farming. It is a concept, and now we have the first prototypes and working system of these kind of resilient smart farming. And how it looks like, it is in our use case, we are talking about resilient edge computing. And what does it mean? We have on the one side resilience and adaptability of systems, IT systems, and on the other hand, the technology of edge computing. It is more system architecture approach, and the basic data processing power at the point of origin of the data. And if you think about agriculture processes, there are many processes on the field, where no good internet connectivity is, and so on. And that is very important for us to bring this concept of resilient smart farming together with the possibility to have more edge computing in these kind of infrastructure for agriculture. We are talking about the Hove box. In our use case, we have this kind of small boxes and hardware and software combination, edge device, and this edge device is called Hove box. Yeah, how our hybrid cloud architecture looks like. On the one hand, we have the edge and hybrid multi-cloud management system, and we have on the right side with the first point the central cloud application, that is the normal one in some kind of central cloud applications in agriculture. In our use case, it is more agriculture meteorology, and also centralized internet dependent software applications for farmers. It's called Geobox Viewer. It's a S3 geodata management service, and this is only in the private and public clouds on our servers. It's only central, and we have to link it into these hybrid multi-cloud management. On the second part, we see now these kind of networks. What does it mean? We have an important level of communication with various networks, like the public 5G networks, and also public long-range wide area networks. It is a IoT network for sensor data. It's quite common in agriculture right now, and these kind of networks we have to know about these in kind of these hybrid cloud architecture, how it's integrated in our infrastructure. And we have also there some kind of software applications for farmers. And then we talk about our resilient edge computing, and that is the core and the main part where we'll talk about, and it's built on the framework of Open Horizon in software as a service by IBM Agri Application Manager on our farm use case. And we have there an innovative IT infrastructure in order to get into the resilience of digital infrastructure. And the third step is the most impressive and innovative one, the way to the edge. We call the third level resilient edge computing. And what does it mean? So we have a resilient framework on it according to our offline first principle, a decentralized data storage for farmers. I hope you noticed what I said earlier before, that agriculture is a good use case because it is a critical infrastructure. And you see there are these three important parts, the edge gateways. In this part, we see now, you see the edge gateways, and you see a regional server between our edge device, our hardware component, and the edge gateway. We have the regional server and our edge device called Hostbox, where we are running some containerized applications on it, like our application, GeoBox application. And what we can do now is to be open for external applications. And it's quite very good and important that we have not only proprietary software which developed by us, we are open for external containerized software, and we can integrate and implement it via Open Horizon framework onto the edge, to the Hostbox. And now we want to look how it looks like in our resilient edge computing and long-range wide area network. And you see now an administrative infrastructure where we have the Open Horizon Management Hub and the Open Horizon Agent. And we have now this kind of Hostbox, our hardware component where we are running an Open Horizon agent, and this is the Hostbox core, and then we get Hostbox container registry. And this part is very important in FDO, and we will look later on. Joe will introduce you what we are doing there. And you see here some kind of container software which are running on our Hostbox core. And what we are doing there is to show the farmers the software by some kind of end devices like the computer or mobile phone and so on. And what we are doing with a long-range wide area network, we can bring the sensor data on the decentral data storage on the Hostbox, because we are running on this box long-range wide area network server, and then we can build a resilient network infrastructure with long-range wide area network. And it's independent from the internet in this time. So we want to show on our Hostbox core, and then we see on this overview, which was developed by IBM and Expedia, you can see the downloaded application on these Hofbox, on this edge device, and this is a part of the running Open Horizon agent, where you can see the kind of applications we are running on these Hofbox. And you see the starting button in order to start the application, GeoBox, on your Hofbox, on your device, and you see some more information about your hardware. On the next slide, you see the available applications on the management hub for this containerized software, and there are some in order to download for your own Hofbox from the management hub of containerized software. It's very good. And you can do that. You can manage thousands of edge devices like Hofboxes. It's very important to understand that this is the core of Open Horizon framework in our use case. If we now go a step further, we see also the LibreOffice and open source software, powerful Office Suite and Screensheets. It's MQTT broker, Eclipse Mosquito. You can run these containerized software and some proprietary containerized software on your edge device. And now for farmers, we are developing this GeoBox application. It's a containerized user software on the Open Horizon agent on the edge. And you see the dashboard of our GeoBox application with some information and applications on it. You have a farm profile. It's a more or less a user profile. You have an own messenger service. It's a peer-to-peer connection. And you can use it as a information channel only in agriculture. A map editor, and what's interesting is we are developing a Watson chatbot for the plant protection service in crop production, and also some kind of table editor for some informations you have on your decentralized data storage as a farmer, and local event store like Buchungsjournal in German. It is a local event store, but it is on RDF and based on OLD, Open Link Data standards, and have standardized ontology on these local event store. It's quite innovative for agriculture, and you see here the gateway for our long-range wide area network and the sensor data of these application. And these are running in our GeoBox application, and this GeoBox application is a containerized software on our Hofbox. And the next slide, the deployment at the test farm location. We have a test farm in Rhineland-Palatinate where we are testing our Hofboxes and edge devices, and also the framework of Open Horizon. And you see on the left side our first prototype. It was a Raspberry Pi 4 GB with a long-range wide area board on it. It functioned quite very well, but it's not so powerful, as you can imagine. And the second prototype Hofbox was a x86, and it was more powerful. And you see it in my screen. I have it here. It's running. It's not a fake. It is running, and it's running good. And we can see it every day, and it's quite good and stable. What was our vision? That we have a simple and commercially available integrated into the Open Horizon. We don't want to create our own hardware in order to running systems. We have to have commercially available hardware in order to run our architecture. And our deployed long-range wide area sensors, you see it here. It is behind the bridge. There's a lake here, and it's running a long-range wide area MQTT broker on the Hove box. And you can deploy some sensors in the field, in lakes, and where you want to use it. The IoT use case are very famous in agriculture, and I think it's increasing rapidly in this kind of sector. And what we can do now is to collect data on a local and decentralized data storage. And these decentralized data collection is very powerful for some kind of developments. If you are thinking on AI tools, which can run maybe on the edge and integrate these decentralized data directly from the sensor network. And we have a higher data protection on these localized, decentralized data storage, increasing the efficiency in sensor networks because of the long-range wide area network, and using established and cheap hardware. These kind of sensors are very cheap and very good. And now I will hand over to my colleague, Joe. And yeah, I'm very happy to be here. And Joe,
yeah, thank you, Daniel.
On the slides.
Sure. So quick recap. What you saw here, what Daniel presented, was we have this idea of off-the-shelf, commercial off-the-shelf hardware, an x86 machine that we can actually purchase today directly from the vendor with FDO support built into it. And the goal here is to automate the process of onboarding that farm computer for a specific farmer. So you've heard Daniel mention Open Horizon several times. Open Horizon is an open source project at LF Edge, and it's designed to do two things. One, to take containerized applications and deploy them remotely with zero touch and a high degree of security. And then number two, to have bidirectional support for machine learning deployment. So that's what Open Horizon itself does. And I put a QR code there, which takes you directly to a YouTube video, I believe, where we show about a quick 3-minute video of exactly what the FDO process is like from start to finish. If you go to the next screen. Okay. So let's see, there we go. Okay, I'm sorry, this is a little bit of an eye chart, but I wanted to show you on the left-hand side, think of a small family farm, maybe 5 acres in size. You have a farmer, you have the fields, you have all the equipment. And what they want to do is to begin to deploy sensors, to collect data, to observe what is happening, and in theory, to catch problems before they become too big of an issue. So to do that, we want to be very judicious in how we deploy technology on the farm itself. But more importantly, as Daniel said, we want what we've done here to be resilient. It has to function without an internet connection. It has to function with people that may not understand IT equipment. They might know how to power cycle a machine, but that's all. So what you'll see here, and I'll just briefly go over a couple of these numbers. On the bottom right, you'll see several items with number 0 in front of them. So the bottom line is the German agencies, both national and regional, will help procure the equipment and bring them to the regional management center, where they will be taken to the regional farm bureau in the bottom center there. So what happens is when a farmer wants to use this farm computer on their farm, they would physically walk over to the regional farm bureau, enroll in the program, all their information would be typed in, and at that point, the bureau would actually register one of these devices for the farmer. What that actually means is putting information about who the farmer is in general, what their purposes would be for deploying the equipment, and so on. And that essentially registers an edge computing node in the management plane up there in the regional management center. And at that point, when the regional management center has received the hardware from the manufacturer, they have the ownership voucher that they've loaded into Open Horizon. And that says right now the regional management center actually has this device, and they associate that voucher with that particular edge computing device. Okay. At that point, the farmer may take that device home, back to the farm, and they will connect power and network. Once that is done, if they have a live internet connection there on the farm, at that point, it will reach out to the rendezvous service from FDO and begin that transfer of ownership process, TO1, TO2, and so on. Once that ownership has been transferred, the farmer is now the owner of the device, and Open Horizon at that point says, here is our agent, which we want you to install on the machine, and here is the default configuration. Once the device installs the agent and registers itself with Open Horizon, at that point, we can actually download and install and run all of the default containerized applications there. So this could be word processing. It could be information related to the LoRa gateway server. It could be information about performing analytics and so on. And in addition, one of those pieces of software is that GIM software that you saw on an earlier screen. And that gives them sort of a marketplace where they can easily, on a web page, say, okay, I want to install this particular container and so on. And that allows the farmer to easily manage what software gets deployed to the computer. Now, one of the interesting things, because this is resilient, let's say the farmer doesn't have an internet connection at all. In that case, they would complete the onboarding at the Regional Farm Bureau itself. But on both of these scenarios, we're currently using the FDO onboarding process from start to finish. And in general, that process of registering the device itself and getting it onboarded, not including downloading the software, typically takes 1 to 2 minutes. So it's very quick. So that's all we had prepared briefly. I wanted to let you know that this is actually happening out in the real world on farms in Germany. It's a real world use case using off-the-shelf hardware. And I guess at this point, thank you very much for listening, and we'll open it up to questions.
Joe and Daniel, thank you so much for that. That's amazing, honestly. I had known about the project, but I hadn't kind of seen it come to life where it is in Germany right now. So that's really, really great to see. If anyone has any questions, go ahead and pop them into the question widget. The question that I had was, so around so what is the timeline that it takes for something like this to get up and running for this particular deployment?
The whole resilient smart farming infrastructure, or specifically
Well,
for
I
one
mean,
farmer?
particularly for what you have going on in the Germany example.
Got it. Daniel, so have you been out to the farm there and seen them actually onboard the device?
Yeah, they're on board the device, and yeah, it is quite complex. It is high complexity in this kind of framework. It was very difficult to find the wide framework software, which is open source and good administrated and good software. And we found it with Open Horizon for 3 years now on, and working.
Got it. Yeah, thank
every
you.
day.
So yeah, one of the tricks for us when we were initially working with DLR and Rhineland-Palatinate was, how do we handle the bootstrapping process, right? Because FDO is very good about performing that transfer of ownership, downloading an initial binary and executing that binary. So the question is, what is in that binary? And then once that binary has been executed, how do you bootstrap successive pieces of functionality? So one of the things that we've done and demonstrated last year at Open Networking and Edge Summit was taking bare metal hardware, installing Red Hat Enterprise Linux, then Microshift, and then the Open Horizon cluster agent, and then having the cluster agent register itself, and then download and run containers. And we demonstrated that live. And in that particular case, with that complex installation, it took about 30 minutes, start to finish.
Oh, that's good to know. We actually had two questions come in at the same time, which are actually very similar, which I guess so it must be a common question. But in terms of value add or measuring success, or what are the metrics that you look at and to measure the impact to the farmers, and also just like general success metrics? And if you're measuring any of that today, is there anything that has been seen so far?
So Daniel, did you want to handle that? I know you're doing both the farm and you're doing some testing with a university.
Yeah, both parts. On the side of the technical part, it was very important to have our first prototype, and that's running and implemented in our framework. That was our first success, because nobody of us knows that is function in this kind of framework or not, and how stable is it, and that is now our first success. That is quite very good. And on the other side, resilient smart farming is constantly developed and measured by academic papers and academic stuff on it that we have.
So from an engineering, from an engineering standpoint, I know the two criteria for success: have we done our job properly? Typically, our number one, when we lose internet connectivity, does it continue to function without a hiccup? And what does that experience look like? The second is, if we lose power, if there's a blackout, a brownout, someone trips over a switch and the box is power cycled, can it then continue exactly from where it left off? Without having, let's say, any data corruption, any file system corruption, things like that. So those are two technical criteria for success.
Which I guess then you can then look at in terms of like cost and productivity savings, because those things continued or, didn't have to be reprovisioned after the blackout or whatever, whatever the thing may be.
Yeah. Ultimately, if there's a problem with agriculture, you want farms to be able to continue to produce their crops and bring them to market. And that's ultimately what we're trying to do here.
Right. So I think that's a good answer to that question. And that's really exciting. Congratulations on all the progress that you've made here. It's really impressive, and thank you for sharing it with our audience.
Thank you very much.
Yeah, thank you.
Thank you very much. Thank you.
Yeah, thank you.